Hi everybody, my name is Injie Chen, and here I present my project, face recognition in MATLAB. First of all, I just give us some brief introduction about face recognition. Recently, it draws a lot of attention. There are two reasons why it becomes now. First is widely commercial used, and another is law enforced application. Widely commercial used is like if you go to Disney, it may be use face recognition instead of fingerprint in the future, and also in bank. And another is a law enforced application. Like a police may require someone put his face on his on the police database. So these two reasons make face recognition popular, and it has an advantage. It's better than password, because sometimes you forgot the password. It happens always, and we have a lot of account on internet. Some may be forgot. And another is a fingerprint. Fingerprint needs people to cooperation. If you want to find someone in a group of people, you can not enforce them. But if you have face recognition, you can find the people, use video or camera. It still has a lot of challenges. First of all, it's 3D. Its face recognition is to recognize 3D object from 2D dimension, 2D image, and earlier research based on 2D object it's not very successful. In 1970s, face pattern techniques, which based on face such as distance between eyes, was designed, but it's not perfect. And there are two reasons. First is different illumination, because of the sun, and in the day or night is different, and the pose who make is different. For example, you may look straight at the camera, or just stand behind the camera. So it's quite different. There are a lot of challenges. In this, I just introduced the PCA algorithm to solve face recognition. PCA represents the principal component analysis. This algorithm is posed by Turk and Pertlin, and its basic idea is a KL transform. This algorithm has a benefit. It will reduce n multiple by n pixels to just less coefficient you need to remember. So it will reduce the calculation, and which is good for efficiency recognition. Let me introduce the KL transform. The first line is the orthogonal space we need to focus on. We need to find this space, and if we find this space, and all our pictures can be represented by this. X is the picture, and this is a orthogonal space, and we just remember n, the number of list is n, and we just need to remember n coefficient is enough, so it will reduce n pixel to just a small n. This is the number of pictures. It reduces a lot. To find this space, we need to construct correlate matrix. We use this as our matrix. This is like a average phase, and this is our picture. And we use this equation. We can get we can establish this equation, and solve this equation. We can get the eigenvalue and the eigenvector. The eigenvector is orthogonal space. That's what we need. Then next thing, we just get a coefficient for x. Get a coefficient for every picture, so you can store in the database. It will reduce a lot of size. Now we just got into the PCA implementation. These 40 people are the picture in the database. We're based on this database and recognize others. You see, they are different, but it's difficult to like this. They are a little similar, even with human eyes. Yeah, there's 40 gentlemen. And the next, okay, you see, based on this equation, and we get an eigenvector. This is the eigenvector represent use pictures, and you can see that with the increase of the number, the picture become trivial. Less feature. So we just need 71 features. We get 20 features, and we get we only need 70 features. And it's more than 90 accuracy, because this is so trivial. You don't need to care about. And this is the average phase. You can see here. Okay, this equation. This is the average phase. It's got by the 200 pictures. The 200 picture. Every person has 5 pictures. So total is 200. This is average average phase. Now we implement. We use those features to reconstruct our data. This is the original phase. Which we need to test whether it's who is it, and is it on the database. But if this picture is same as the database, it will construct exactly. It will become very clear they are same. But if this picture is not from our database, it may be a little different. The construct is not so good. You can see another picture. Here is it. This is from the database, and finally, it's perfect construction. And this is not from database. A test picture, so it's different. It's like a blur. but actually it's good enough for us to recognition whether is it who is it. Here this is our picture. This is the test picture, and this is the gentleman our algorithm recognize. This is and those are the correct recognition. You can see they are all correct. The same person, you see, these two. This is test, this is recognition, test, 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 recognition. But they are also have something wrong. This like this. We give this picture, but he think these people is this, which is wrong. Same here, long, long, long. Totally, we use 200 to test, and we get 88 accuracy. Summary: PCA reduce a picture. I mean, this is the pixel, the number of pixels to the number of a picture coefficient in data in base space. So it will reduce a lot of work, easier. And but it still has a lot of problem because when the database increasing, the base vector is very difficult to recognize, and they were very big and efficient. So that's all, and I will implement my code to you. Let me see. Oh, this is the eigenphrase function. It's like to extract the eigenphrase from 200 pictures. I'm read from this place, and then I will get through like some algorithm. I will save in this place. So you can see here, this is the test and the database picture store. You can see here this person. So finally we got like this. This is the 200 phrase eigenphrase through this we can run. You can see I will store in the test average and test picture. Test picture. Yeah. Yes, this one. Yeah. And the second program is to reconstructor. It's not very difficult. We just use 15 and 50. 100 and 150 face to reconstruct. Here you can see the result. That's it. Okay, I just run. It started at the test 2. See, it's 15, 50, 100, 200. Original. This orange. Okay, and then I just give you. Oh, this is the whole face recognition, and it will implement the reconstruct and of recognition. I store the value. If it's correct, I will store in list. If it's not, and the picture name is different. You can see here. So I run it, and okay, it's still wrong. Okay, I get the accuracy of 88, which is very good. And I also store the picture in my test. And original. Here you can see this is recognition correctly. So I can show you this. Next one is correctly. They are same person, but they are still something wrong. For example, this and this is wrong. Here we go. Here he think this is the wrong recognition. You can see here. Not the same person. That's I got. And finally, it's 88%, which is good. Thank you. That's my presentation. Thank you.